Yeah, let's work these two sums again because they're very important from the examination point of view. Now, Avinish.
Ma'am.
Yeah. Yeah, initiate the answer for this one. What will be the first step?
Ma'am.
Sure.
Avinish.
Ma'am, we did this already.
Yeah.
Oh, okay.
Ma'am, we have to separate it in.
No, you don't have to explain. Just tell me, just dictate and I'll write it. That's all.
Minus 1 into 7 whole power 2
Whole power?
into 2.
Minus 2.
Minus 2, sorry.
Yeah, close your book. Just see the question on the screen and tell me. Don't read from your book.
Into 3 power minus 1.
Minus 1 into
11 power minus 2.
Okay, into
A power minus 2. 4.
Divided by
uh, 2 into 11 whole power
2 into
minus
11.
4.
Correct.
Into 3 into 7 whole power minus 3. Into A minus power minus 6.
Okay. So what have we done? We have written minus 7 as when the base is negative. Minus 7. We write it as minus 1 into 7. And all other composite numbers like 22, we write that as 2 into 11 and 21 as 3 into 7. The other bases are prime. So we just write them as it is and A also as it is. So we've written the prime bases 3 and 11 as it is. The prime basis 3 and 11 as it is, A as it is. Minus 7 is prime, but we write minus 7 as minus 1 into 7. And 22 and 21 are composite, so we write them as a product of their primes. 2 into 11 and 3 into 7. Okay. Next step, Navneet.
Yes, ma'am. Ma'am, minus 1, bracket minus 1, raised to the power minus 2 into 7 into 7 raised to the power minus 2 into 3 raised to the power minus 1 into 11 raised to the power minus 2 into A raised to the power minus 4 by 2 raised to the power minus 4 into 11 raised to the power minus 4 into 3 raised to the power minus 3 into 7 raised to the power minus 3 into A raised to the power minus 6.
So Navneet, what's the rule we have used here? Complete this. A to the power m into b to the power m. Sorry. A into b the whole power m is equal to A into b the whole power m is equal to. This is the rule we've been using, right? Now we are writing 2 into 11 the whole power minus 4 as 2 to the power minus 4 into 11 to the power minus 4. So what's the rule you've been using?
Ma'am, A into B raised to the power whole raised to the power m is equal to A raised to the power m into B raised to the power m.
Correct. This is the rule we've been using. Okay. Now, children, the next step, minus 1 to the power minus 2 into, I'll just arrange, the terms. Now, see here. We have base 3 to the power minus 1 into 7 to the power minus 2 into 11 to the power minus 2 into a to the power minus 4 divided by 2 to the power minus 4. Under this 3, I'll write 3. 3 to the power minus 3 into 7 to the power minus 3 into 11 to the power minus 4 into a to the power minus 6. I've just rearranged the terms. Children. See, in both the numerator and denominator, we have the base 3, 7, 11, and A. In both numerator and denominator, we have the bases 3, 7, 11, and A. 3, 7, 11, A in the numerator, 3, 7, 11, A in the denominator. See, we have 3, 7, 11, A base in the numerator. We have the same 3, 7, 11, and A in the denominator also. Apart from that, we have -1, the whole power -2, and 2 to the power -4. You can also write the step as, see here, you can also write the step like this. -1, the whole power -2 by 2 to the power -4 into, see here, into 3 to the power -1 by 3 to the power -3 into 7 to the power -2 by 7 to the power -3 into 11 to the power -2 by 11 to the power -4 into 8 to the power -4 by 8 to the power -6. You can also, for better understanding, you can also write it like this. See, if you have 2 into 3 into 4 by 10 into 20 into, say, like 16, you can write it no as 2 by 10 into 3 by 20 into 4 by 16. You can write it like this. 2 into 3 into 4 by 10 into 20 into 16 can be written as 2 by 10 into 3 by 20 into 4 by 16. That's what we have done here. So we've written these two, -1, the whole power -2 by 2 to the power -4 into base 3, base 3, base 7, base 7, base 11, base 11, base A, base A. Now, when bases are same and it's division, we subtract the powers. Before that, what do we do with this? Here the power is negative. In both of them, the power is negative. You want to make it positive. So just exchange their places. See here. This 2 to the power -4, it's in the denominator, right? When you write it in the numerator, the power becomes positive. The negative power becomes positive. -1 to the power -2 is in the numerator. Write it in the denominator. Don't change the base. Don't change the base. Okay, the negative power will become positive. Remember that. When you write something which is in the numerator, in the denominator, if you switch the places, if you switch between the numerator and denominator, write the opposite power. Please understand this and let me know if all of you understood. -1 to the power -2. Where is it? Numerator. Where have we written? Denominator. How have we written? We have written the base as it is. We did not change the base. Actually, we have changed the base, but now you're hearing this for the first time. So we'll just understand like this. So -1 base I've written as it is. The power -2 is now +2. 2 to the power -4. It's in the denominator. Now we have written it in the numerator. That base 2, you write it as it is. The power -4 becomes +4. All right, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Now here tell me 3 to the power -1 -3, correct? Into 7 to the power -2 -3 into 11 to the power -2 -4 into 8 to the power -4 -6. Correct? -16 by -1 into -1 into 3 to the power minus 1 plus 3 into 7 to the power minus 2 plus 3 into 11 to the power minus 2 plus 4 into a to the power minus 4 plus 6 is equal to 16 into, because you know minus 1 into minus 1 is 1. 3 to the power 2 into 7 to the power 1 into 11 to the power 2 into a to the power 2. So this is 16 into 9 into 7 into 121 into a square. What's the product? 121968. 121968 is 12. All right?
Yes, ma'am.
Yes, ma'am.
All right. Written as minus 1 into 8, the whole power minus 2. Minus 8 should be written as minus 1 into 8, the whole power minus 2. And you know 8 is 2 cubed. So change that. 8 is 2 cubed. Minus 1 into 8. 8 is 2 cubed. The whole power minus 2 into 5 to the power minus 3 into minus 7 is minus 1 into 7. The whole power minus 4 into 2 to the power 4 divided by minus 5 is minus 1 into 5. The whole power minus 7 into 28. Find the prime factors. 2, 14 times 2, 7 are 7 ones are. So 2 squared into 7. The whole power minus 3 into 16 is 2 to the power 4. The whole power 4. 16 is 2 to the power 4, but there's already the power 4 there. So 2 to the power 4, the whole power 4. This one is 2 to the power 4. The whole raised to the power 4. Next step, the rule is a to the power, a into b, the whole power m is equal to a to the power m into b to the power m. A into b, the whole power m is equal to a to the power m into b to the power m. So minus 1 to the power minus 2 into 2 cubed power minus 2 into 5 to the power minus 3 into minus 1 to the power minus 4 into 7 to the power minus 4 into 2 to the power 4 divided by minus 1 to the power minus 7 into 5 to the power minus 7 into 2 squared, the whole power minus 3 into 7 to the power minus 3 into, you'll have to multiply the power, so 60. And then now we'll just multiply these powers and then use the law of exponent, which says base the same multiplication, add the powers, division, subtract the powers. So we'll just simplify this first. So we have minus 1 to the power minus 2. Okay.
Ma'am,
Into
just one.
2 to the power minus 6 into 5 to the power minus 3 into minus 1 to the power minus 4 into 7 to the power minus 4 into 2 to the power 4 divided by minus 1 to the power minus 7 into 5 to the power minus 7 into 2 to the power minus 6. So we've multiplied. Now you can simplify the numerator and simplify the numerator denominator separately. So we have base minus 1 here and here in the numerator. We have base 2 here and here in the numerator. And we have base 2 here and here in the denominator. So we'll simplify them. We'll simplify the numerator and the denominator separately. In the numerator, you have 2 terms with base minus 1. And you have 2 other terms with base 2 in the numerator. The numerator, we have 2 terms with base minus 1 and 2 other terms with base 2. denominator, we have two terms with base 2. We'll simplify them. Bases are same, multiplication, add the powers. The others, we'll write them as they are. So the numerator will have -1. The power is -2 and -4. Add the powers. -2 plus -4. Add the powers into 2 raised to the power -6 and 4. -6 plus 4 into 5 to the power -3 and 7 to the power -4. 5 to the power -3, 7 to the power -4 as it is, divided by, we write -1 to the power -7 as it is, into, we'll simplify this, 2 to the power -6 plus 16. 2 to the power -6 plus 16 into 5 to the power -7 as it is, into 7 to the power -3 as it is. So we have -1 to the power -2 -4 is -6 into 2 to the power -2 into 5 to the power -3 into 7 to the power -4 divided by -1 to the power -7, 2 to the power 10 into 5 to the power -7 into 7 to the power -3. Now it's division. Bases are same and it's division. So we'll subtract the powers. -1, -6, -7 into 2 to the power -2, -10 into 5 to the power -3, -7 into 7 to the power -4, -3. Because now it's division, so we have to subtract the powers. So we have -1, -6 plus 7 into 2, -12 into 5 to the power -3 plus 7 into 7 to the power -4 plus 3. So it's -1 to the power 1 into 2 to the power -12 into 5 to the power 4 into 7 to the power -1. Now after this, what you have to do is, there are two terms with a negative power in the numerator. Take them to the denominator. We have 2 to the power -12 with a negative power. Write it in the denominator, the power becomes positive. 7 to the power -1. Okay, the power is negative there. So write it in the denominator, the power becomes positive. The remaining two terms, you can write it in the numerator itself because the power is already positive. So write it in the same position. And -1 to the power 1 is -1 into 5 to the power 4. -1 to the power 1 is -1. 5 to the power 4, the power is positive. So write it in the numerator itself. These two terms, the power is negative. So change the position. Put them in the denominator. Then -12 will become +12, -1 will become +1. So this is -1 into 625 divided by 4096, right? Into 7, which is -625 divided by, what was the product? 4096 into 7.
Ma'am, 4096. Ma'am, 28672. Ma'am, sorry, ma'am. 28672.
Correct.
Yes, ma'am.
Correct. All right. Next one. Yeah. Take down the question. So when it's division, what do? You subtract the powers, right?
Powers. Ma'am, when it's division and the base are same, we subtract the power.
Yeah. So this is the question. This is the question. So on the left-hand side, you see the bases are same and it's division. So we have to subtract the powers. So write the base as it is. Write the base as it is. Subtract the powers. 3m minus minus 6 is equal to 4 by 7 to the power minus 9. So this is 4 by 7 to the power 3m plus 6 equals 4 by 7 to the power minus 9. Now, this is an equation. You can see the equal to sign, it's an equation. The earlier questions were just expressions. See, this question is just an expression. It's not an equation. Here, this is an equation. You can see the equal to sign. Okay, and you have to find the value of m. Now, the left-hand side is completely simplified. You cannot do anything more with the left-hand side. Similarly, the right-hand side was already simplified. There's nothing you can do with the RHS. In the left-hand side, here, we were able to use the rule. Bases are same, it's division, subtract the powers. So we used that rule and we simplified. And we have got this result. Now, this cannot be simplified further. And this one, which was already in the RHS, you cannot simplify that further. So now when the left-hand side and right-hand side are completely simplified like this, okay, then we can use this rule. If the bases are same on both the sides, equate the powers. If the bases are same on both the sides, on either sides, we have the same base, 4 by 7, 4 by 7. It's like they get cancelled. 4 by 7 gets cancelled on both the sides. You should not cancel, but you just look at it like that, as if 4 by 7 gets cancelled on both the sides. So what are you left with? 3m plus 6 is equal to minus 9. They are in the power. Okay, 3m plus 6 and minus 9 are the powers. But now that's what is left. So 3m plus 6 is equal to minus 9 is the equation. Now solve this. 3m is equal to minus 9 minus 6. 3m is equal to minus 15. M is equal to minus 15 by 3. M is equal to minus 5. So what we say is when bases are same on both the sides, you can equate the powers. When bases are same, we can equate the powers. Yeah, please write down. So the value of m is 5.
Done, ma'am. Done, ma'am.
Okay.
Done, ma'am.
Okay. All of you finished?
Yes, ma'am. Yes, ma'am.
Okay. Okay. This you can understand. Just write down the question and work the answer. The heading is write the following in the expanded form. Write the following in the expanded form. So these numbers are given to you and you'll have to write them in the expanded form. So this is the place value chart. 10 to the power 0, 10 to the power 1, 10 to the power 2. This is a decimal point. 10 to the power minus 1, 10 to the power minus 2. So it goes on 10 to the power minus 3 and so on. Yeah, this is self-help. Understand, go through, understand, and then write down. I'll come back in 5 minutes. Completed, children?
No, ma'am.
Okay, fine.
Done, ma'am.
Completed, children?
Yes, ma'am.
Okay. Yeah, if you have any doubt, you can ask me. Or if it is not, like clear, if it was really, not self-help and has to be explained, please tell me. The place value chart goes like this: decimal point. To the left of it, we have 10 to the power 0, 10 to the power 1. See, that's what we normally have, decimal point. Then we have ones, tens. Let me write it in words. We have ones, then tens. I'm sorry, just a minute. I'll take a different slide. Yeah. So we have ones, tens, hundreds, thousands, 10,000s, and so on, right? Then we have the decimal point here. Then we have tens, one tens, one hundreds, hundreds, THs, thousands, right? Thousand and thousands, THs. Okay. So ones means, what is one? Anything to the power 0 is 1, right? Anything to the power 0 is 1. So we say 10 to the power 0. 1 is 10 to the power 0. Then what is 10? 10 to the power 1 is 10. What is 10? Once is 1, right? So 10 to the power 0 is 1. Then tens, that is 10. 10 to the power 1 is 10. Then hundreds, 10 squared is 100 because 10 into 10 is 100. Then 10 cubed is 1000. 10 into 10 into 10 is 1000. 10 to the power 4. 10 into 10 into 10 into 10 is 10,000. 1/10, meaning 1 by 10. This is 1 by 10. This is 1 by 100. This is 1 by 1000. 1 by 10 is 10 to the power minus 1. 1 by 100 is 10 to the power minus 2. And 1 by 1000 is 10 to the power minus 3. Why? Because 1 by 10 is 10 to the power minus 1. You understand, because reciprocal of the base, negative of the power. The reciprocal of 1 by 10 is 10. And the power, you don't see any power there, which means it's 1, negative of the power, so minus 1. And what is this one? 1 by 100? It's nothing but 1 by 10 the whole squared. 1 by 100 is 1 by 10 the whole squared. Reciprocal of the base, negative of the power. 1 by 100 is 1 by 10 the whole squared. Reciprocal of 1 by 10, 10. Negative of 2 minus 2. So 1 by 100 is also 10 to the power minus 2. 1 by 1000, it's 1 by 10 the whole cubed. Reciprocal of the base, negative of the power. So the place value chart goes like this: decimal point, 10 to the power 1, sorry, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, and so on. And here you have 10 to the power minus 1, not 10 to the power minus 0, okay? 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, and so on. So you just have to write the chart and write the digits under the respective place value. So see a decimal point, 10 power 0, 10 power 1, 10 power 2, 10 power minus 1, 10 power minus 2. That is the place value chart. Now write this number, under the respective, write the number, meaning write the digits under the respective place value. So you can see this decimal point here coming here, 987, 789, and 42. So what will be the expanded form? 9 into 10 to the power 2 plus 8 into 10 to the power 1 plus 7 into 10 to the power 0 plus 4 into 10 to the power minus 1 plus 2 into 10 to the power minus 2. Multiply the digit with the respective place value. 9, the digit is 9 into the respective place value 10 to the power 2 plus the digit is 8 into the respective place value 10 to the power minus 1 plus the digit is 7 into the respective place value 10 to the power 0 plus 4 into 10 to the power minus 1 plus 2 into 10 to the power minus 2. That's what it is everywhere. And you don't have to show like 0 into 10 to the power minus 1. When the digit is 0, 0 into 10 to the power minus 1, you may write or you can ignore. If you write, fine. If you don't write, if you don't show that also, it's good. It's okay. 0 into 10 to the power minus 1, you can write or just ignore. When the digit is 0, you can even ignore it. Yeah, this is self-help. So this is write the following in the decimal form. The expanded form is given to you. Here the decimal form. In the earlier question, the decimal form was given to you. Decimal form was given to you, and you had to write the number which was given in the decimal form in the expanded form. So here it was decimal form to expanded form. In this question, it is expanded form to decimal form. They're all in the expanded form. Write the decimal form of these expansions. So actually, you should be able to write it without using the chart, children. Now see here, what are the place values like? Decimal point, 10 to the power 0, 10 to the power 1, 10 to the power 2. And then here, 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, right? So just write the place value chart. You should actually have it in your mind. Now just fill it. What is under 10 to the power 0? 5. What's under 10 to the power 1? 6. What's under 10 to the power minus 1? 8. What is under 10 to the power minus 2? It's not given, so 0. 10 to the power minus 3, 3. So this is the number, 65.803. If under a particular place value, there is no digit, write 0. If under a particular place value, there is no digit, then it is 0. You should fill that emptiness with 0. Okay, I think we'll do this together. So this is the first one. The second one, children, see your decimal point, 10 to the power 0, 10 to the power 1, 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. Second one. All right. So now under 10 to the power minus 2, we have 4. Under 10 to the power minus 3, we have 5. Then here under this one, nothing, so 0. Then this decimal point as it is. Here also nothing. So the number is 0.045. For the second one, the number is 0.045. Do it again. See, this is the chart. Decimal point, 10 power minus 1, 10 power minus 2, 10 power minus 3. And before this, we have 10 power 0, 10 power 1, and so on. So now 10 to the power minus 2, the digit is 4. 10 power minus 3, the digit is 5. Now here there is no digit, 0. Decimal point. Here also no digit, so 0. So 0.045 is the number. Third one, 10 to the power 2, 10 to the power 1, 10 to the power 0, decimal point, 10 power minus 1, 10 power minus 2, 10 power minus 3. So 10 power 2 is 5. Here nothing is given, 0. 4, decimal point, nothing is given, 9, 6. This is the number, 504.096. Yeah, write down.
Ma'am,
Yeah.
ma'am, actually, I did the first one before. I like wrote the question like above each statement, like 6 into 10 raised to the power 1. And then below that, I put an arrow and then I put like 6, 5.803. Is it fine? Or should we do it in the table manner?
No, you can write the decimal value straight away. You can do that.
Oh, okay, ma'am. Thank you.
No, but now that you finish it, you can just write down this instead of just waiting for the others to finish.
No, ma'am, I've still not finished yet.
Okay.
Ma'am, I joined now only. Now have you completed those three sums?
No. Write down.
Okay, ma'am. Done, ma'am.
Yeah. Okay. So here the heading is express in standard form. So standard form, has two parts. In the first part, see, in the first part, you'll have to write a value which is 1 or anything more than 1 but less than 10. And the second part, you must write 10 raised to any integer. 10 raised to any integer. The first part, so the standard form is basically a product. The standard form is basically a product. Okay, something into something. Now the first part takes a value 1 or anything more than 1 but less than 10. The second part is 10 raised to any integer power. Raised to any integer power. Okay. Now let's see the first one. 0.12345 zeros and 5. Now you'll have to bring this number. See, so standard form looks like something into 10 to the power something like this. This is how it looks like. Into 10 to the power dash. All right. Now the decimal point is here. Now the value of this number is less than 1. The value of this number is less than 1. Now let's shift the decimal point. 1, 2, 3, 4, 5, 6. Supposing we get it here. What's the number? It is 0.5. No, it is less than 1. But we are looking for 1 or anything more than 1 but less than 10. We are looking for 1 or anything more than 1 but less than 10. Supposing you put the decimal point here. So from here, 1, 2, 3, 4, 5, 6. You drop the decimal point here. The number is 0.5. That's less than 1. So 7, bring it here. Now it becomes 5. Yeah, 5 is more than 1 but less than 10. So that is acceptable. So it is 5. The number in the first dash is 5. Now, by shifting the decimal point like this, you have increased the value of the number. The number, was so small. It was 0.0000005. It was so small. By shifting the decimal point, you have increased its value to 5. This number's value is now 5. You have increased it to 5. So when you increase the value, you must raise 10 to a negative power. When you increase the value, you must raise 10 to a negative power. If you decrease the value, you must raise 10 to a positive power. Opposite effect. If you increase the value, the number given is small. You have increased its value to 5. You've already increased. No, so don't give a positive power. You've already increased. So increase and positive are like same. Decrease and negative, they're like same. So if you increase negative power, if you decrease positive power, like you're giving the opposite effect. You have to give the opposite effect. If you increase the value, see, increase, positive, they're like the same. Increase and positive. Decrease and negative, both are the same. So we have to give the opposite effect. So if you increase the value of the number, raise 10 to a negative power. If you decrease the value of the number, you've already reduced it. No, you've decreased the value of the number. So raise 10 to a positive power. Give the opposite effects. Increase negative power. Decrease positive power. If you increase give a negative power, decrease positive power. So here the number was so small. Now we have increased its value to 5. So raise 10 to a negative power. And that power will be the number of places you have shifted the decimal point. 1, 2, 3, 4, 5, 6, 7. You have shifted the decimal point by 7 places. So 10 should be raised to a negative 7. Negative 7 because we have already increased the value. So negative power. So this is how you express a number in the scientific notation or the standard form. Scientific notation or the standard form. Let's do it again. 0.000005. We'll have to bring this number to a value which can be 1 or anything more than 1 but less than 10. Minimum value is 1. Minimum value is 1. It can be 1 also. Minimum value is 1. Maximum value is less than 10. It cannot be 10. You cannot write 10 also. Less than 10. Like you can write 9.99, but not 10. You can write 1 or anything more than 1, but less than 10. Okay. So now this number, shift the decimal point. 1, 2, 3, 4, 5, 6, 7. When you bring the decimal point here, the number becomes 5. Okay, and 5 is between 1 and 10. Good. So we've got the first part. Into 10 to the power, the number given is small. You have increased its value to 5. You have increased its value to 5. So if you have already increased, so raise 10 to a negative power. And what will be the negative power? The number will be the number
Ma'am,
of
the
times.
number of the decimal part.
The number of times we have moved the decimal point. So 1, 2, 3, 4, 5, 6, 7. We've moved the decimal point by 7 places. So raise 10 to a negative 7. I'll do the next one also for you. 0.12345636 is equal to. Now see here. 1, 2, 3, 4, 5, 6, 7. You need to stop here. Because no, you will have questions to answer by yourself. Now it's time for me to explain to all of you so that all of us understand. 1, 2, 3, 4, 5, 6, 7. So now the number becomes 3.6, which is between 1 and 10. 3.6. 1, 2, 3. 3.6. Yeah, it's between 1 and 10. Okay, so we've got the first part into 10 to the power. The number was 0.00000036. Such a small value. You have increased it to you have increased it to 3.6. It was 0 point something. It was not even 1, it was 0 point something. You have increased its value to 3.6. So already you've increased, right? So raise 10 to a negative power. Negative. So the decimal point we shifted by 7 places. So negative 7. Next one. 126.03. The decimal point is here. No. I'll give you questions. Okay, the decimal point is here. 1, 2. So it becomes 1.2603. The decimal point is here. The number is 126.03. It's so much more than 10. 126.03. 126.03 is more than 10. So you'll have to bring it to a value less than 10. So the decimal point is here. If you put it here, it will be 12 point something. No, it's more than 10. See, the number is this one. If you move the decimal point here and stop, it is 12.603. 12 is more than 10. So don't stop here. Move it here. 1.2603. Yeah, 1 point. It's more than 1, but less than 10. So the decimal point is here. You shift it by 2 places to the left. 1, 2. And the number is, the new number is, Anirudh, you'll have to wait. I have not asked anybody to answer now. So 1, 2.
Oh.
2 places. All right. Now we've already decreased the value of the number. The number given is 126.03. 126.03. Now we have reduced that to 1.2603. 126 has become 1. The value is reduced. So raised 10 to a positive power. By how many places did you shift the decimal point? 1, 2 places. So positive 2. Now tell me. Tanvin? Yeah, answer this one, Tanvin. Where is the decimal point?
Ma'am,
Where is the decimal point in this number?
ma'am, after 0.
Yeah, it's here. If it's not there, it's here. It's here. Yeah. Yeah. So tell me, 1, should I stop here?
No, ma'am.
2, should I stop here?
No, ma'am.
3, should I stop here?
No, ma'am.
4, should I stop here?
No, ma'am. Oh, yes, ma'am.
Yes. We have to stop here. We have to stop here. So what's the number? What's the number now?
8.09.
8.09. 00, but you can just ignore this because the zeros in the extreme end have no value. So you can just ignore that. Okay, so 8.09. Now this value is between 1 and 10. 8 point is between 1 and 10.
Yes, ma'am.
Yeah, into 10 to the power. Have you increased the value of the number or reduced?
Reduced, ma'am.
What is the given number?
Given number 80,900.
80,900. And what is it now? It is 8.09. So clearly you've reduced the value of the number, right? So you should raise 10 to a positive or a negative power.
Yes, ma'am. Ma'am, we should raise, ma'am.
No, you should raise 10 to a positive or a negative power.
Ma'am, negative.
1 second. There's somebody at the door. Just a second. Yeah, I'm back. So 80,900 is now 8.09. Clearly the value is reduced. So we need to raise 10 to a positive power. We have shifted the decimal point by how many places? 1, 2, 3, 4 places. So raise 10 to a positive 4. Yeah, Akshita, next one.
Ma'am,
Where's the decimal point?
ma'am, after two places, ma'am.
It's here. The decimal point is here. Okay. So shall I put it here?
No, ma'am.
What is the number when you shift it here?
Ma'am, 222.2, ma'am.
Yeah, it's more than 10, correct?
Yes, ma'am.
Okay, shall we move it here and stop? What's the number now?
22.22, ma'am.
Is it more than 10?
No, ma'am. Yes, ma'am. Yes, ma'am. It's more than 10, ma'am.
It's more than 10. Okay, so now we'll move it here. What's the value?
2.222, ma'am.
2.222. Is 2.222 more than 1 and less than 10?
Yes, ma'am.
Yeah. So the number is 2. The first part is 2.222. The first part is 2.222 into 10 to the power. What is the given number, Akshita? What's the number given to us?
2,222, ma'am.
Okay, now it has become what? 2.222.
Yes, ma'am.
Have you increased the value or decreased the value?
Decrease the value, ma'am.
Decrease. So opposite effect will be positive or negative power.
Negative, ma'am.
No, you've decreased it already. You've already decreased it.
So positive, ma'am.
Positive power. Okay. So by how many places did you shift the decimal point?
3 points, ma'am.
1, 2, 3. So raise 10 to a positive 3. Plus 3 or simply 3. Okay?
Okay, ma'am.
Very good. Yeah. Yeah. Take down the answers, children. I'll give you more questions for you to practice. Please work.
Ma'am, done, ma'am.
Yeah.
Done, ma'am.
Completed, all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Now in this question, we'll have to express in the usual form. The expressions given are in the standard form or the scientific notation. We'll have to put the number back in the usual form. 7.89 into 10 to the power minus 7. So this is nothing but 7.89 divided by 10 to the power 7. You understand how to write this? I told you, no? If you switch the places, now 10 to the power minus 7 is in the numerator. If you bring it to the denominator, write the power with the opposite sign. So it's minus 7. If you write it in the denominator, it becomes 10 to the power plus 7. Now this is nothing but 7.89 divided by 1, 2, 1, 2, 1, 2, 1. So what is this? This is something which you already know. How do you write 5 by 100? 0.05, right? How do you write 1 by 1000? 0.001. Yes or no?
Ma'am, 0 point after we put 6 zeros and write 7, 8, 9.
Yeah. So 1, 2, 3, 4, 5, 6, 7. 7.
Ma'am,
So we'll have to
0.
we'll have to move the decimal point to the left by 7 places because we have 7 zeros. We have 7 zeros. We'll have to move the decimal point to the left by 7 places. So see here. Just put some zeros. If see here, 1, 2, 3. Just put how many zeros here? 7, no? 1, 2, 3, 4, 5, 6, 7. And then write that number which you have there. Then just write the number you have there. How many zeros are here? 1, 2, 3, 4, 5, 6, 7. No? 1, 2, 3, 4, 5, 6, 7. Then after that, I just wrote this number 7.89. Now shift the decimal point. It's here, no? So 1, 2, 3, 4, 5, 6, 7. So this is the answer. 0. Do this in the rough column. 0.000000789. Dilute again. See here. The given expression is 7.89 into 10 to the power minus 7. First step, 7.89 divided by 10 to the power 7. 10 to the power minus 7 is in the numerator. Write it in the denominator. Minus 7 becomes plus 7. Now this is nothing but 7.89 divided by 1 followed by 7 zeros. 7 zeros. So now this is something which we've come across earlier. Like I was telling you, if you have 3 by 100, we know it is 0.03. So in the same way here, you just have to shift the decimal point to the left. Okay. So we have 7.89. So see here, how many places to the left? 7 places because 7 zeros. So see here, 1. It comes here. 2, 3, 4, 5, 6, 7. It comes here. So these gaps are filled with zeros.
Okay, ma'am.
Fill the gaps with zeros. I'll show that again. I'll show this part again, children. You'll have to shift the decimal point to the left by 7 places because 7 zeros, 7 places. So see here, 7.89. 7 zeros. So you'll have to shift the decimal point to the left by 7 places. So it's here, 1, 2, 3, 4, 5, 6, 7. It comes here. The decimal point is here. Now, fill these places with zeros. And of course, before the decimal point, you can put a 0. So this is the answer. It is 0.000000789.
Ma'am, I
Yeah,
got
right.
same answer.
Yes, ma'am.
Ma'am, can I do the last one?
Yeah, tell me.
Yes, ma'am. So it is 2.5. 2.5 54.
Ma'am, no, ma'am, can I tell? Ma'am, it is 254 followed by 7 zeros.
Correct. Correct. 2.54 into 10 to the power 9. Into 10 to the power 9 means 1 followed by 1, 2, 3, 1, 2, 3, 1, 2, 3. So you'll have to multiply. You'll have to, now here the power is not negative. Yeah, you can disable your mic. Here the power is not negative, it's positive. So it's 2.54 into 1 followed by 9 zeros. So this is nothing but 254 because after the decimal point, there are already 2 digits here. So of the 9 zeros, we'll get only 7 zeros. 1, 2, 3, 1, 2, 3, 1. Or When you multiply, what will you get? When you multiply, what will you get? You will get 254 followed by, when you multiply, you will get 254 followed by 9 zeros, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then you'll have to place a decimal point, right? We'll place it here. So the answer is nothing but 254 followed by 7 zeros.
Okay.
Done, ma'am.
All right.
Done, ma'am.
Yeah. Yeah. So write this one in the standard form, 0.00022. Work this and tell me the answer.
Done, ma'am.
Yeah. What's the answer?
Ma'am, it's 2.2 into 10 to the power minus 4.
Yeah, disable your mic, Anirudh. Very good.
Okay, ma'am.
0.00022. So we know when we have to write a number in the standard form, it's a product with two parts, where the first part is 1 or anything more than 1 but less than 10. So the decimal point is here, 1, 2, 3, 4. You should bring it here so that it becomes 2.2. So 2.2, which is between 1 and 10, into 10 to the power. The number here is 0.00022. It's 0 point something. And now it is 2.2. You have increased the value. So you should raise 10 to a negative power. You have increased the value, so negative power. And what is the number? 1, 2, 3, 4. You've shifted the decimal point by 4 places. So minus 4. Correct. Next one.
Ma'am, can I say?
Yes.
Ma'am, the answer is 5.24 into 10 raised to the power 6.
Correct.
Yes, ma'am.
So the number is 524 followed by 4 zeros, where the decimal point is here. So you'll have to move it by 1, 2, 3, 4, 5, 6 places, so that it becomes 5.24, which is between 1 and 10. Now the number is so large and you have reduced it to 5.24. It's become small now. The number is large. Now it's reduced. to 5.24. So because you've reduced the value, you must raise 10 to a positive power. And you've shifted the decimal point by 6 places. 1, 2, 3, 4, 5, 6. So it's a positive 6.
Done, ma'am.
Okay. Next one, we'll just work this and wind up the session for today. Yeah, complete these 3 and we can wind up the session for today. Yeah, what's the answer for the first one? Sahasra?
Yes, ma'am.
Yeah, 3.48 into 10 to the power 5 is nothing but 1 followed by 5 zeros, correct?
Yes, ma'am.
Now when you multiply, what will you get? You'll get 348 followed by 1, 2, 3, 4, 5 zeros. And you'll have to place a decimal point, right?
Yes, ma'am.
Where should I place a decimal point?
Before 2 zeros.
Yeah, here, correct?
Yes, ma'am.
Yeah, so the answer is 348 followed by 1, 2, 3 zeros. Okay. The next step, the next one, Sahasra, see it's 10 to the power minus 4. So since the power is negative, write that in the denominator with a positive power. So 10 power minus 4, which is in the numerator, becomes 10 to the power 4 in the denominator.
Yes.
So that's nothing but 1.54 divided by 1 followed by 4 zeros. Now tell me what's the answer?
154 followed by
1.55. No, divided by.
oh,
Yeah, so you'll have to shift the decimal point to the left by 4 places. 1, 2, 3, 4. All right?
yes.
Yeah, so it will be the decimal point comes here. So 0.000. So what's the answer? It is 0.000154. I'll just show you that again. See here. When you're dividing, you should shift the decimal point to the left. Because when you divide, the number becomes small, no?
Yes.
When you divide 1.54 by 10,000, the number will become small. So you should shift the decimal point to the left. 1.54. You should shift by 4 places. This is 1, 2, 3, 4. It will come here. It's here. So you can put a 0 here and 3 zeros here. So it's nothing but 0.123154. Last one.
It is 0.
Where is the point, decimal point now? Is it before 4 or after 4?
Before 4.
It's after 4. 4 is 4.0.
Oh,
4 means it's 4.0. The decimal point is after 4, not before 4.
okay, ma'am.
Yeah. So it's 4. The decimal point is here. You'll have to shift it to the left by 1, 2, 3, 4, 5 places. So it's here. 1, 2, 3, 4, 5. And it comes here. Fill these gaps with zeros. So the answer is 0.00004.
Okay, ma'am.
Yeah, right on.
Done, ma'am.
Done, ma'am.
Done, ma'am.
Done, ma'am.
Okay, if you have not finished, please take a screenshot. It's time. We have to wind up the class. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thanks.
children.